Good morning. Graph is a very, very important component of physics. And understanding graphs as per your AS mathematics is definitely very, very important in understanding how to answer questions for graphs. First, let us continue with graphs and kinematics. Displacement time graph, velocity time graph, and acceleration time graph. So, what is so important about graphs? As you can see, there are a few graphs that are listed here and what you need to know in kinematics. But what is important is gradient. Gradient. Now, gradient of a graph sometimes represents something, sometimes do not represent anything. But for displacement time graph, the gradient represents the velocity. And for velocity time graph, there's another component which is the area, which represents the displacement. So in any graph, you always look for number one, gradient. What does it represent? Number two, area. What does it represent? Number three, relationship of variable components to determine the shape of the graph. And of course, number four, the linear law. All this I will go through when the time comes, when we have questions on these components. But I would like to emphasize that in graphs, these are the four components you're looking for: gradient, area, relationship of variable components, and the linear law. Let's start with our kinetics. Now, the first question, the graph shows how a physical quantity varies with time. Okay, let's try and answer this question. Which event could best be represented by the graph? The acceleration of a firework rising to a maximum height and falling to the ground. So when you talk about the acceleration of free fall, you either take it as positive only or negative only in the graph. So in this graph, the quantity is both positive and the negative part of the graph. So this is not possible. The acceleration of a skydiver leaving an aircraft, falling, operating a parachute, and falling to the ground. This is possible. Let me explain to you later. I will explain to you the others first. Why is it not possible? The speed of a javelin as it leaves an athlete's hand, falls and sinks into the ground. So in this question, you have to understand the components of vector and scalar. So speed is a scalar quantity, and in a graph, a scalar quantity is always positive. So there are two, the graph goes in positive and negative. So this is not possible. So it's only positive speed. Speed of a high jump athlete leaving the ground, jumping over a bar and descending to the ground. Okay, this speed again, not possible. So the answer is B. Why? The acceleration when a skydiver falls, the acceleration will decrease to zero as the air resistance increases and equal to the weight. Here, zero. So when the skydiver opens the parachute, the air resistance will be larger than the weight. And therefore, the component of the acceleration becomes negative. That is why at this part, it is negative. And the acceleration, the negative acceleration will decrease until it reaches terminal velocity again when the acceleration is zero. So the answer is B. 2. A parachutist falls vertically from rest at time t equals 0 from hot air balloon. She falls for some distance before opening her parachute. Which graph best shows the variation with time t of the speed of parachutist. So here, you have learned in O levels, the first part of the graph is the graph of terminal velocity. And the only graph that shows that is this. Terminal velocity here, and opening parachute here, terminal velocity with the parachute again. The car travels along a straight horizontal road. The graph shows the variation of the velocity v of the car with time t equals for 6 seconds for its journey. The brakes for the car applied from t equals to 1 second to t equals 4 seconds. How far does a car travel while the brakes are applied? So you need to find the area below the graph. It's here. From 1 to 4. So that you can find the area of a trapezium. This is 8. This is 32. And this is 3. So it's 15 times 3, 45. A mass on the end of a spring bounces up and down as shown after being released at time t equals 0. Which graph shows how the velocity varies with time? Distance up, distance down. So, the velocity of the graph is the gradient. So you just look at the gradient of the graph. So over here, the gradient is 0. Over here, the gradient is 0. Over here, the gradient is 0. So the graph can either be all these three. This three, where it starts with the gradient of 0. But there are two other times when the gradient is 0. Where the speed is, the velocity is 0. Okay? So, this is not possible. This is possible. Huh? So it's an oscillating spring where the velocity is positive and negative. So in this part of the graph, gradient positive, velocity positive. This part of the graph, gradient negative, velocity negative. So the answer is A. A skydiver jumps from an aeroplane and falls vertically through air. Which graph shows a variation in time t of skydiver's vertical velocity? So this is a terminal velocity graph, and the obvious answer is C. The graph shows the variation of velocity with time t for an object. The object passes a fixed point at time t equals 0. What is the displacement of the object from the fixed point at time t equals to 5? And what is the acceleration of the object? So the velocity of the object at time t equals to 5, or this displacement, sorry. So you need to find the area. So again, trapezium, half times 4 plus 24 times 5. So it's 28, 14 times 5, 70. So these two answer. And the acceleration is the gradient. So the gradient is 20 over 5 equals to 4. And the answer is B. The velocity time graph of an object of mass 2.5 kilogram is shown. What is the resultant force acting on the object? So this one you have to. What is resultant force? This is Newton's law. Huh? Newton's law, as you have studied in your O levels, F equals to ma, the easy one. So you have just to find the acceleration, which is 9 over 15. which is 3 over 5. So the force equals to 2.5 times 3 over 5. So this 0.5 times 3 equals to 1.5. Okay. We're going to do a few questions only today. The tennis ball is released from rest at time t equals 0 and falls through air for a long time. Which graphs of its displacement against time t represents the motion of the ball? So its important word is air. So it is terminal velocity. But this is a displacement time graph. So at the terminal velocity, the gradient of the graph must be a straight line because the velocity is constant. So the only graph that shows an increasing gradient and then finally an increasing gradient and finally a constant gradient. We should tell you that this is the answer. The diagram shows graph of various quantities plotted against time for an object dropped from a stationary balloon high in the atmosphere. Which statement could be correct? So this is a terminal velocity graph, so this can be a well, but velocity time graph. And as the graph falls, the acceleration decreases to 0. So this can be acceleration time graph. So answer is C. The velocity of an electric car changes as shown. What is the acceleration of the car, which is the gradient? So it is 105 over 4. About there. So the answer is about 26. Student cycles uphill from time to shop, taking 10 minutes. The student then spends 5 minutes in the shop before cycling home downhill at twice the initial speed. Which graph shows the variation with time of the distance traveled by the cyclist? So what is the important words here? Distance. Distance is a scalar quantity and it must always take a positive value. So if you say that the return is twice the initial speed, so the gradient must be 2 times when it returns. Or you can say that the time taken is half. So if you look at this graph, the gradient here is 2 times the gradient here. So this is the answer. The graph shows how the velocity of a ball varies with time t from the moment it is hit vertically upwards from the ground. What is the displacement of the ball from the ground after a time of 3 seconds? So you're talking about displacement. Excuse me, there's some technical error. Okay, never mind, you just use the green. So the displacement here is positive, and the displacement below the graph is negative. So here, the displacement is half times 2 times 20, which is equals to 20. Here we'll have negative replaced displacement half times 10 times 1, which is equals minus 5. So 20 minus 5, displacement is 15. Remember, in the velocity time graph, the displacement below the graph represents a negative displacement. An object falls from a tall building. The graph shows how the velocity of the object changes with time t. The acceleration of free fall is g. What describes the acceleration of the object at t equals to y and t equals to z? So again, it's a falling object. The acceleration of the gradient is decreasing here. So at y, the gradient is decreasing, the acceleration is decreasing. And over here, the gradient is 0. And therefore, the acceleration is 0. Answer is B. An object moves in a straight line. The graph shows the variation with time t of the velocity v of the object. Time t equals 0. The object is at point x. What is the displacement of the object from point x at time t equals 0 to t equals 0.8? So over here, the area is half times 0.2 times 2. 0.2 negative. So up to 4, the area is half times 0.6 times 6, 1.8 minus 0.2, 1.6. This graph shows the variation with time t of the velocity v of an object falling vertically downwards in a vacuum. So in a vacuum, there is no air resistance. It is falling with an acceleration of free fall. So it must have a constant gradient. So if it's falling, you take the velocity downwards at positive. So the velocity would be increasing. D. Last question. A steel ball is dropped from rest from a height h above the ground. The ball hits the ground after time t. This is represented for a number of different heights. The graph shows the variation h of with t square for the ball. Okay, so it's h against t square. So h, you use the kinematics formula S equals ut plus half at square. Huh? So S as the h equals to half at square. In the linear law, this will be a straight line graph. So the gradient is half gt. Half g, sorry. The gradient g. So the g will be 2 times the gradient, which is this answer. Thank you very much. Today, if you like my lessons here, you can like and receive more physics video and maths video in the future. Thank you.